Hello everyone. First thing I'd like to do today is go over the homework answers. You can either, if you were not here, you might want to listen to my whole explanation. If you were here yesterday and you just want to check your answers, feel free to skip ahead on this part and just make sure your answers are correct. The main thing today we're going to be focusing on is Trig Part 2. So we're going to be focusing on finding angles and also word problems. But first, let me go through my answers on last night's homework. So if I want to find the sine of m, remember m represents the angle of which you are looking from. So if I was looking at m, this side would be the opposite of m, this side would be the adjacent, and this side would always be the hypotenuse. So based on the idea of the memory trick of SOHCAHTOA from yesterday, if I'm thinking sine, I'm thinking opposite over hypotenuse. So the sine of angle m should be 16 over 30. But good for you if you knew you had to reduce. You can divide these both by 2 and get the answer of 8/15 is your final answer for number 1. The cosine of z, so you're looking at this triangle from the perspective of this angle. So this would be your opposite side, this would be the adjacent side, and this would be the hypotenuse. So if I was trying to find the cosine of z, you're really thinking adjacent over hypotenuse. So the adjacent to this would be 12. The hypotenuse would be 20. You can take a 4 out of both of these, so that can reduce to 3/5. Okay, and remember every time you go through one of these, your perspective does change. So I'm going to erase what I've had here so far, because now we're going to be looking at the tangent of L. So if I'm looking from the perspective of L, I'm thinking that tangent really represents opposite over adjacent. So opposite and adjacent would be opposite over adjacent would be 30 over 16. You can divide those both by 2. So your final ratio will be 15 over 8. The sine of x, so we're looking from this perspective. The sine is defined as opposite over hypotenuse. So opposite would be here, hypotenuse would be here. So the ratio is 12 over 20, which again, both can be divided by 4. So that ratio would be 3/5, just like the cosine of z above. Number 5, the cosine of L. I might need to scroll back up here for a minute. So the cosine of L, if we want to move a little bit more quickly now, cosine is adjacent over hypotenuse. So if this is L, I'm thinking the ratio would be 16 over 34. Both of these are divisible by 2. So 8/17 is the proper ratio. And then the tangent of z, looking from this perspective, tangent is opposite over adjacent, or in this case, 16/12. If I divide these both by 4, the final ratio would be 4/3. So again, I hope that helped if anyone needed the description, but I'm going to keep moving on to the next answers. This is asking which trig ratio best corresponds to each value. So what this problem is saying is if you're looking from the perspective of g, it wants to know what 9 over 41 really represents, which trig function. Because 9 is opposite of the angle, and because the 41 is the hypotenuse. Again, if you think about SOHCAHTOA, that should look more like an H there. If you think about SOHCAHTOA, you have opposite and hypotenuse, which makes me think that the best trig function for number 7 is sine. And if I erase this and do this in a different color here, if I'm looking from the perspective of angle H, and I look at 40 and 9, 40 compared to this angle is opposite, and 9 compared to this angle is the adjacent side. Opposite over adjacent is tangent. So I said that the trig function that best describes the situation is tangent. We did 9 and 10 in class. For those that were not here, please make sure to take a look at the notes online. Here is my attempts. Here are the answers for number 11 and 12 in terms of the work. If 15 is your reference angle, remember you never use the 90 as the reference because the 90 represents that you can use trig in the first place. Comparative to this angle, the 25 is the opposite and the D is the hypotenuse. So again, just to kind of get this memory trick down, I just keep rewriting it. SOHCAHTOA, we have opposite and hypotenuse. So again, my eye goes towards sine. So you would say that the sine of 15 degrees, for those that were here yesterday, please remember that I kept saying that sine without an angle is sin. Sine means absolutely nothing without this angle. So sine of 15 is the same as the opposite over hypotenuse, or sine of 15 equals 25 over d. Yesterday, if we wanted to cross multiply this, we wrote this over 1. And then we said d times the sine of 15 degrees equals 25. And if we wanted to get d alone, we divided both sides by the sine of 15. And so if you plug in 25 divided by the sine of 15 degrees, my final answer was d equals 96.59, whatever units. So we can just write units for now. Make sure, again, that your calculator is please in degrees, otherwise you'll be getting these wrong. The second triangle, I based everything off of this angle 12, and based on that, E looks like it's the opposite side, 4 looks like it is the adjacent, not the hypotenuse, which makes me think, if I'm thinking about my trig, I'm thinking TOA this time, or tangent. So my equation would be that the tangent of the angle, again, a trig function means nothing without the angle. Tangent is defined as opposite over adjacent. So tangent of 12 degrees equals opposite E over the adjacent 40. If I put this over 1 and cross multiply, we would have 1 times E, or E, equals 40 times the tangent of 12 degrees. And if you plug in 40 times the tangent of 12 degrees, you would get E equaling 8.50. So those are the answers to last night's homework. Let's keep going to the new notes. So your notes again should be on green, called Trig Day Part 2. Let's take a look at a couple of these warm-up questions. So warm-up problems. Given the following triangle, find the cosine of C. Well, in order to find cosine, that means I need to use trig. And in order to use trig, that means I must have a right triangle. So if we're taking a look at number 1, we don't currently have a right triangle, but in all seriousness, you're going to hear me say this a lot, when in doubt, other than take out a GCF, when in doubt, draw an altitude. So you might want to consider drawing an altitude down. So now we have 2 right triangles. If we're trying to find the cosine of C, that means we're trying to find not necessarily what the angle measures, but the ratio. Because this is an isosceles triangle, because of 13 and 13, I know that these 2 triangles eventually will be congruent, which means that this bottom is bisected into 5 and 5, which means that the height must be 12. So now if I'm interested in finding the cosine of angle C, cosine is defined as the adjacent over the hypotenuse, or the cosine of C is really adjacent 5 over hypotenuse 13. I could have gone a step further also and asked you for the sine of angle C, and if I did that, that would be opposite over hypotenuse, which would be 12 over 13. So this one was good to remind you that you should draw an altitude if you're ever given a triangle and you want to use trigonometry. Another good problem based on yesterday's lesson, before we get into anything new, is something without a picture. If the tangent of M, if the ratio is 6 over 8, find the sine of M. Well, it looks like we have nowhere to start until we remember that tangent is really opposite over adjacent. So if I wanted to draw a triangle, I know it has to be right in order to use trig. If I call this angle M down here as a reference point, the opposite side is 6 and the adjacent side is 8. So without doing much work, I know that this side has to be 10 because of the 3, 4, 5 triple multiplied by 2. So now I'm actually able to find the sine of M, or the ratio of the sine function at angle M. Sine is defined as opposite over hypotenuse, so the sine in this case would be 6/10, or even better, 3/5. So both of these examples are good for drawing a picture when you need one. And things like this will come up on future homework assignments. All right, now comes time for the actual new notes. And what we're going to be focusing on here at the beginning is using trig ratios to solve for angles today, not just sides. So 1 and 2 were the warm-up problems, but now let's get to examples 3 and 4. I have a little picture of the calculator here that I think might help some of you see. So if you don't have your calculator out, I would really consider having it there because it's going to help doing this along with me. Now, if we take a look at examples 3 and 4, both of these this time are not asking you to find a side length. It's asking you to find a missing angle. The good news is that we can still use trigonometry for this. So if I take a look at my reference angle, it doesn't matter that we don't know it, because we still do know that the 8 is still opposite of this reference angle, and 12 is still the hypotenuse of this reference angle. So I'm just going to keep writing this on every single page. I'm sure some of you may have it memorized already. My eye goes to sine, because I have opposite and hypotenuse sides. So let's say I make an equation. The sine, remember sine without an angle is sin. So the angle, even though we don't know it, A, has to be attached to the sine. So sine of A equals opposite over hypotenuse, or that the sine of A equals 8 over 12. And so the question becomes, how do I get rid of sine? How do I know how to get A alone? Because it looks like it's almost alone except for that tiny little A. Now, unfortunately, a very common mistake is for students that think they can just divide both sides by sine. But that doesn't work again because remember, sine without an angle means nothing. So instead, I want you to think about inverses. The opposite of, or the inverse of addition to subtraction. The inverse of multiplication is division. So the inverse of sine is something called the inverse sine, and it is abbreviated as sine -1 in your calculator. Now, if you take a look at this little calculator over here, if you look at the sine button, which is right here, you might notice that the writing right above is the inverse symbolism. If you want to get to that button on your calculator, what you're going to do is press second sine. And when you do that, the inverse sign should pop up on your calculator. Now, before we actually get into plugging that in, I want to show you why this does work. So let me rewrite the equation as I see it. Sine of A equals 8/12. There's a reason I'm leaving a little room. If I want to get rid of the sine function, the only way to legally do so is apply the inverse on both sides. So sine inverse and sine are inverses, so all that's left is just the angle. But on this side, we're left with inverse sine of 8 over 12. So what you would do in the calculator is use the inverse sine function. You would press second sine, and in your calculator, you should see this symbolism here. Now, trig, normal trig, is when you plug an angle in and get a ratio out. Inverse trig is when you have the ratio, which we have 8/12 this time, and what we're going to get out is the angle. So if you press second sine and plug in 8 over 12 into your calculator, if your calculator is in degrees, the final answer I had was 41.81 degrees. Now the second example, I'm going to use C as my reference, and I noticed that 12 is the adjacent side, or the side next to C, and 20 is the hypotenuse. So if I was asking myself which trig function, this time I would look at cosine because I have adjacent and hypotenuse. So if I were to use the function, I would say that cosine of C, of the angle, is equal to adjacent over hypotenuse. Or the cosine of C is equal to 12 over 20. If I legally want to get rid of cosine, I have to apply the inverse cosine to both sides of the equation. Over here, they would cancel, and you'd have the angle by itself equals the inverse cosine of 12 over 20. So in the calculator, the only thing that would differ this time, I'll do it in red again so you can see it, you would just press second and then cosine this time. The inverse symbolism would come up, and all you would do is plug in 12 over 20, and if you did that correctly in the calculator, you would get 53.13 degrees. So the videos can only be 15 minutes. So what I'm going to ask you to do is, before you go to the next video, I would like you to try these next two problems, 5 and 6. At the start of the next video, I will have all of my work and the final answers for those. So please don't start the next video until you've tried 5 and 6. Thanks guys, and see you at the next video.